Hello everyone. Welcome to Week 2 lecture videos part 3. In the last two videos of this week, we learned about how to calculate present value and future values. Now, sometimes we use some shortcuts to calculate present values and future values when the cash flows are longer, and these shortcuts makes our life easier. So first shortcut that we use is perpetuity. Perpetuity is basically an asset that pays a fixed sum each year for an indefinite period. Okay, so when we say a perpetual cash flow, we actually indicate to a cash flow that is supposed to continue for an indefinite period, and the cash flows are occurring at a regular interval with the same amount. Okay, and this is the simple formula to calculate the return on a perpetual cash flow, which is cash flow that comes every period and divided by the present value. And this is how we calculate the present value of a perpetual cash flow, which is periodic cash flow divided by discount rate. Okay, so no matter how much cash flow comes, because the cash flow will be same every period and it's supposed to continue for an indefinite period, we take the cash flow and divide it by discount rate to get present value. So look at this example. What's the present value of $1 billion every year for all eternity if you estimate the perpetual discount rate to be 10%? So your periodic cash flow is 1 billion and your discount rate is 10%. So what's the present value? As we already know, present value is a cash flow divided by discount rate. So the present value of this perpetual cash flow is $10 billion. Okay. Now, sometimes this perpetuity can be starting at a future period rather than starting at the immediate period. So in our previous example, as we have seen, that 1 billion is a periodic cash flow and we are dividing it by the discount rate to get the present value, it is impliedly assumed that the cash flow starts in year 1. Now look at this example. What if the investment does not start making money for 3 years? It means that it's a perpetual cash flow. You get the same cash flow every year. However, the cash flow doesn't start for 3 years. Okay, that means it's a perpetuity starting in some future period. So this is how we get the present value. We still have the same present value formula. So periodic cash flow divided by discount rate. Okay, so this is the present value of the perpetual cash flow. However, this is the present value of the perpetual cash flow 3 years from now, because the cash flow starts after 3 years. Since this is the present value of the cash flow 3 years from now, we again multiply it by a present value factor, which is 1 divided by 1 plus interest rate power 3. So this present value factor is multiplied by the present value to get the present value at 0 time period. I repeat, this is the present value of the perpetual cash flow in year 3. And this is the present value of the cash flow in year 0, I mean now. Okay, so when we have a perpetual cash flow starting in some future time, we first of all need to use the formula to calculate the present value of the perpetual cash flow. Then we need to multiply it by the present value factor to get the present value of the cash flow at 0 time period. The next shortcut is an annuity. So annuity cash flow is somewhat similar to perpetual cash flow. Only difference is annuity cash flow occurs for a specific number of periods. Okay, so perpetual cash flow continues for indefinite period, whereas annuity cash flow continues up to a certain number of years. But annuities still have the similar characteristics like equal cash flow at a regular interval. So the present value of annuity formula, this is the periodic cash flow multiplied by 1 divided by r, that is interest rate, minus 1 divided by r into 1 plus r power t. So this is the present value annuity factor. So previously we have seen present value factor. Now this is present value annuity factor. Okay, so this is present value annuity factor. It means that this is the present value of an annuity where you get $1 every period up to a certain number of years. So look at this example. You have a series of cash flow where you are getting $5,000 every year up to year 5. Now, to get a present value, what you need to do is you get the present value of this 5,000, present value of this 5,000, this 5,000, this 5,000, and this 5,000. If you sum them up, that is the present value of cash inflows. Now you can see that this is a 5-year cash flow. Sometimes you may have a 10-year, 20-year, or even 50-year cash flow. In that case, finding out the present value for each of this cash flow and then summing it up can be a time-consuming task. Now, if it has an annuity characteristic, what is that? You can see that you are having equal cash flow every year and the interval is regular. So it's an annuity cash flow. So rather than going for a time-consuming process of calculating present value of each of these cash flow and summing them up, you can simply use the annuity formula to get the present value. Okay, so in that case, $5,000 will be your cash flow, this one, and you use interest rate and the time period, you can simply get the present value of these cash flows using the present value annuity formula. Okay, so let's see another example. The state lottery advertises a jackpot prize of 590.5 million paid in 30 installments over 30 years of 19.683 million per year at the end of each year. If interest rates are 3.6%, what is the true value of the lottery prize? Okay, so you are actually winning a lottery and you get the money in 30 installment. Each installment is 19.683 million per year and your interest rate is 3.6%. So you can see that it has an annuity characteristic. What is that? You are getting same amount every year up to 30 years. So you can use the annuity formula. This is a cash flow, then 1 divided by R minus 1 divided by R into 1 plus R power 30. And you can see the present value, I mean the value of this cash flow that you expect to receive over 30 years, value of this cash flow now is 357.5 million. Now we need to understand the difference between different types of annuity. Now annuity can be ordinary annuity can be annuity due, and sometimes, not very common, annuity can be a deferred annuity. As I said, that annuity means the cash flow is coming for a certain number of periods at a regular interval. Now, if an annuity starts at the end of the first period, then it's called ordinary annuity. And if annuity starts immediately at 0 time period, then it is called annuity due. Okay, let's say this is a timeline. This is 0 period and this is period 1. Okay, now, and let's say this is period 2. Now when we say ordinary annuity, the cash flow starts here. Let's say $100 and $100. This is ordinary annuity. Now if cash flow starts immediately, let's say $100 here and $100 here, then it is annuity due. Okay, so you can see in both cases you get $100 at a regular interval for 2 periods, but in this case $100 starts at the end of first period, and in this case the annuity starts at the beginning of the period. So at the end of period 1, this is ordinary annuity and this is annuity due. Okay, so and this is the formula for annuity due. You can see present value of ordinary annuity, the formula that we have seen earlier, and we just multiply 1 plus R. Okay, and this is future value of an annuity due. This is future value annuity multiplied by 1 plus R. So when we have an annuity due, we first calculate present value of an annuity using the formula we have seen previously. We just multiply an additional term, which is 1 plus R. So look at this example. Suppose you invest 429.59 annually at the beginning of each year. You can see this beginning of each year at 10% interest. After 50 years, how much would your investment be worth? So since it's starting at the beginning of each year, it is an annuity due. Okay, so since it's an annuity due, you use this formula. So 429.59, that's is a periodic cash flow, then future value of an annuity, and we multiply by 1.R, which is an additional term. So the future value of the investment will be 550,003. Now another example of an annuity paying off a bank loan. So far we have seen that we have a periodic cash flow, we have interest rate and time period. We calculated present value of the cash flow, I mean present value of annuity. Now is there any other use of this formula? Yes, there is. Look at this example. You are purchasing a TV for $1,000. You are scheduled to make 4 annual installments. Given a rate of interest of 10%, what is the annual payment? So now you can see that you are purchasing the TV of $1,000, which is basically the present value of an annuity. Okay, because you are supposed to pay 4 annual installments, so which is an annuity payment. Interest rate is 10%. Now this is the present value of the entire cash flow, but you do not know what is the size of your each installment. Okay, so you can calculate by solving this equation. So this $1,000, this is the present value of your cash flow. So 1 divided by R minus 1 divided by R into 1 plus R power T, that's the present value annuity factor. What we don't know is what is our periodic payment. Okay, so if we solve for this PMT, we get 315.47, so which is the installment payment, which is the periodic installment payment. So this is the future value of annuity formula. So we have seen the present value annuity formula. This is future value of annuity formula. You can see this is the periodic cash flow, and this is the future value annuity factor. Okay, so when we are calculating future value annuity, we are basically calculating what will be the value of a series of cash flow that occurs for a certain time period in a future date. Okay, look at this example. So what is the future value of $20,000 paid at the end of each of the following 5 years, assuming your investment returns 8% per year? So you can see that it's a periodic cash flow because you are paying $20,000 every year and the end of each year. So it's not an annuity due, it's an ordinary annuity because the amount is paid at the end of each year and your interest rate is 8%. So this is your periodic cash flow and this is your future value annuity factor. The 1 plus interest rate power T, which is 5, divided minus 1 divided by interest rate. So 117,332, which is the future value of this cash flow after 5 years. Now, a slight extension of the perpetuity. You can remember we defined perpetuity as a series of cash flow that continues for an indefinite period with the same amount of cash flow every period coming at a regular interval. Now, sometimes it might be possible that perpetuity is growing. Perpetuity growing means you still have the cash flow continuing for an indefinite period. The cash flow is still coming at a regular interval, but the cash flow at each time period is not same. Cash flow is growing. If that's the case, then we get the present value using this formula. You can remember previously when we talked about perpetuity, the present value formula was a cash flow divided by the discount rate. We didn't have this part, okay? We didn't have this part. So it was only cash flow divided by the interest rate. assuming that the cash flow will be the same every year. Now, if we have a growth rate, then we have this term, R minus G, to calculate the present value. So you can, so you can see this is the cash flow coming at year one, R minus G. This is the rate of return or the cost of capital minus growth rate. So look at this example. What is the present value of $1 billion paid at the end of every year in perpetuity, assuming a rate of return of 10% and a constant growth rate of 4%? So you can see that this is your cash flow, $1. 10% is the cost of capital and 4% is your growth rate. So 10% minus 4%, you can see that present value is $16.667 billion. So the present value of this growing perpetuity is $16.67 billion. So you can remember we had a similar example previously when we did not have this growth rate. Okay, we did not have this growth rate, so we only divided 1 by this 10%, and the present value of that cash flow was $10 billion. So when there was no growth in the cash flow, the present value of that perpetual cash flow was $10 billion. Now, since we are having a growth rate, I mean the cash flow is growing, the present value increases to $16.667 billion. So you can see that the 6.667, this part is basically coming for the growth in the cash flow. So this is the end of our discussion on the annuity and perpetuity. Please see the next video for a discussion on effective interest rates. Thank you very much.